So let's start the meeting. So good morning, good afternoon, good evening, everybody. So depending where you are on Earth. So I wanted to make this meeting to one month after the beginning of the O4 run, just to make a brief status of how it's going this how this offer run is going for all of us, and also to collect your feedback about this first month of run. As you know, not so many things happen, but there are still things to discuss, and a few alerts to show you. So where are we after the first month of O4? So I have just few points to discuss to show you, but it's very light. So I will just show you a few interesting things about how to monitor the status of the GW detectors and the latest information we have. Then we will make a brief overview of the different alerts that have been detected so far during this first month of O4 by LIGO and mainly by the two LIGO's detectors. And maybe for some of you who wonder why you didn't receive any alerts since the 24th of May, I will try to give you answers why you didn't receive anything yet. And finally, we could have a quick, not quick, we have time, but we could have a discussion about your personal feedbacks, and we'll just give you some also feedback I got by discussing with some of you on Slack or by email. Okay, so let's start with the status right now of the O4 run. So actually, as you know, we had an announcement just before the beginning of O4 that the Virgo interferometer will not participate to the beginning of the O4 run, and mainly to the first 6 months of the O4 run, so which means from June to August, if I'm correct. The time for them to correct the problem they encountered before the O4 run. And so Kagra is here, but I mean Kagra doesn't have the sensitivity to reach the distance horizon that are interesting for us, and basically Kagra doesn't go much outside of the Milky Way in terms of distance horizon universe, the volume of universe that it can scan for merger events. So finally, for this first 6 months of O4, we will rely on the two LIGO detectors. So just remind you that these two LIGO detectors are located in the US, Livingston and Hanford here. Here. So the direct consequence of this, and especially to not have Virgo in the loop here, is that we will probably have poor localization accuracy of each DW event because we will only have one or two detectors detection. So the more detectors you have to localize the source, the better will be, of course, the accuracy of the localization in the sky. So that's the main issue that we are going to face for the first 6 months. Okay. Just wanted to show you. So you have here the link. You can check this link if you are curious. That you can check, actually monitor the duty cycle of the different GW interferometers. So you can see that Virgo has a flat, completely empty active periods. So this period was just for for yesterday. So they make this kind of plot every day on real time, and so I just took a snapshot of this let's say operating duty cycle of the interferometer at that time it was supposed to know. So you can see that Livingston has some holes sometimes, also Hanford has some holes sometimes. You can see also GO600. GO600 is here in the Europe. We do not use this interferometer for our astrophysical purpose, major events at cosmological distance or extragalactic distance at least. And it was just to show you that the duty cycle of GW interferometers is it's not 100% once they are on. Sometimes for any reason that I don't know, because I'm not an expert at all of this kind of machinery. But it's just to show you that the duty cycle is not only 100% over a day. They are part of the time that when the detectors are not taking data. This is also shown here in this plot that shows you, so still for the day before, but you can, if you click on this link here, you will have the status of today, where you see here the average distance horizon for BNS detection. For LIGO Hanford in red and for LIGO Livingston in blue. So you see holes here in the different times here corresponding that to the time where the detectors is not taking data. And you can see that for LIGO Hanford, we have a poorer distance horizon sensitivity. Well, it's not that much compared to Livingston, around 140 megaparsecs. And for Livingston, we are almost at 160 megaparsecs. So this is an average range. It doesn't mean that these detectors cannot detect BNS at 200 megaparsecs, but it's just to give you the average range of distance for BNS merger detections. And of course, Virgo is not appearing in this plot because Virgo is not active now. But hopefully, after August of this year, we will see the Virgo line here, and hopefully, we hope to have Virgo lines at the highest here level possible. We will see actually. Okay, so these are the plots I wanted to show you for the rough overview of the GW detectors sensitivity and duty cycle. So don't hesitate if you are curious or if you have time sometime to check this, check this URL to just if you want to see when Hanford and Livingston were taking data, things like that. Now we are going to go to the different alerts that have been produced by the two LIGOs detectors this last month. And so I encourage you also, if you have time, if you want to have also an overview from your own perspective, to go onto this URL here that lists actually all the public alerts that are sent by the LIGO Virgo Cagra collaboration for the O4 run. And you will find both what they call significant detection and what they also call low significant detections. And this corresponds to events that have a false alarm rate of 1 event per month, if I'm correct. And so far, we got 9 significant detection candidates from LIGO Virgo. Actually, we got 11 candidates, but 2 were already retracted later by the LIGO Virgo Cagra collaboration. Among these 9 candidates, we got, let's say, one more or less clear neutron star black hole binary system merging on May. You got the date here. So for those who are not familiar with the name of the GW event, so you have here the year, you have here the month, you have here the day, and here you have letters corresponding to the chronological order of the detection. So A is the first of the 29th of May 2023, and BC, so etc. etc. We got a few days ago another interesting candidate, where we don't know if it's actually an NSBH candidate or just a binary black hole merger. So you can see the probability of the chance probability of being BBH or NSBH are very close and very close to 50-50. So it's hard to say if it's a completely a BBH or NSBH. I guess offline analysis will help to disentangle between the two classification. And we got 7 binary black hole mergers. So I've listed here with a high probability of being a binary black hole merger. So it's quite secure BBH merger events. I just show you here two sky maps. These are the two sky maps of the NSBH candidates. So you have the sky map of the event of 2 days ago here, S230627C. And you have the sky map here of the event of May, so 230529 AY. And as you can see, you have a huge difference between the different sky maps, where you have on the right side here one detector detection. So it shows you how critical it is to have only one GW detector detecting something in the sky, especially in NSBH modeliness. So you can see that, well, the detection was area at 90% confidence level covers almost half of the sky. So 24,000 square degrees. So it's a huge, well, a huge part of the sky to cover. But on the contrary, we got this guy 2 days ago with a very, well, let's say, well-localized event for GW localization typical accuracy, where we got at 90% confidence level a localization better than 90 degrees, square degrees. So that was for the significant events. So for the, let's say, secure binary merger events. So no BNS events right now, unfortunately. And I just wanted to show you how the insignificant or low significant events look like. So actually we got 144 alerts from LIGO Virgo Kaga collaboration for this kind of low significant detection. So it's kind of subthreshold events. I have to mention that for significant events, you have people from LVK collaborations that are going to check the data, etc., send circular, GCN circular, then to confirm the event or to retract them. But for this low significant detection, you have no human in the loop to validate them. So they just send the alerts and you do whatever you want with this. They will not provide any updates or any circular confirming or retracting the event. And it concerns actually all types of GW events that these detectors can detect, and typically BBH, BNS event, binary neutron star merger event, NSBH, terrestrial, or burst. These are the classification by all types of events. I mean the classification that is given by the algorithm they have to provide this short latency classification. I just show you some sky map of typical events. So typically for burst events, you have a very interesting sky map that looks like this, which looks completely crazy, but very interesting in terms of artistic point of view. You have, if I remember well here, this one was, I think, a BNS classified low significant event. You have here a terrestrial, so typically a glitch, a noise in the detector that triggered the algorithm, the detection algorithm. And so here I found, I think it was a BBH classified low significant event. This is just to show you how diverse are the sky maps, and also how different are the sky maps compared to the, well, don't look at this right sky map, it's one detector, but how diverse and different they look compared to, let's say, two detectors well-localized GW event. So we have a lot of them, and so usually we don't look at them for Grandma, but also for Kilonova Catcher, we don't send any alerts related to this kind of event, even if it's classified as, for example, this one was classified as a BNS at 73% confidence level, if I remember well, but we don't send anything about this because it's complicated to do things with this. All right. I just wanted to show you what the table I showed you in our last general meeting on April 27th. If you remember well, I tried to describe these numbers that come from the LIGO Virgo user guide for the electromagnetic counterpart or the astronomers, let's say. And I tried just to see if the current alert rate we got from LIGO Virgo is compatible with the expectation. Well, there are different hypotheses here, but let's say it's just to have a rough idea of where we are for the beginning of this first first month of 04. So in terms of NSBH, we got 2, let's say, per month. So let's say that from 24th of May and right now it's 1 month. The expected rate, if I take the number here, should be for the whole. It's for the whole 04 run. Should be around almost 0 to 1.4 NSBH per month per year. So this is based on per year annual number of public alerts. For BBH, we got seven events per month, and so we are supposed, based on this number here, 260 plus or minus this error, we're supposed to expect 9 to 49 events per month. And for BNS, we got 0, as you know, significant event per month, and we were expecting 1 to 7 BNS per month based on this number and the errors we got from these expectations. Which means that in terms of NSBH, we might be still compatible with the highest boundary of the expected rate of the 04 run. While for BBH and BNS, the alert rate is right now a bit low compared to the expectation, and so we will see if in the coming months we are more in agreement with the expected rate. I have to confess that those numbers are based on the first month of 04. There is no Virgo in the loop, so we have to be careful in interpreting this, but that's the reality of what we have right now.
Damien, I think we have a question from Michael.
Yeah, I was just going to clarify. I think because when we did the observing scenarios, we did assume Virgo, we assumed Kagra, we assumed the LIGO detectors at kind of full freight. And so my suspicion is 04B is kind of the time at which I'd expect this level of things. And so it'll be a bit before we're quite at these rates, I suspect.
Yeah, I agree. Thank you. So anyway, we will keep monitoring these statistics. I think, of course, LIGO Virgo collaboration is going to do the same thing, but it's still interesting to have this in mind. Of course, in this, as Michael said, in this annual number of public alerts, there are a lot of hypotheses that are actually not compatible with the reality we face right now. Last item I wanted to discuss is about the grandma alert. So I had got a lot of feedback from people asking me why I don't have any grandma alert. Did I make something wrong, or my setup configuration is not correct, etc., etc. So I will show you that no, it's normal if you didn't get any alerts. And so to start with, I just wanted to show you the the filters we've set up on Grandma to send you alerts, so to the Kilonova Catcher astronomers. And so first of all, we right now do not process the binary black hole merger events, even if they are very, 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 very well localized. Right now, it's not in the loop. I could add them, of course. It's everything is doable, but right now, just to let you know that it's not in the loop of the alert we are going to send to you. For the binary neutron star mergers, these are the different thresholds the event have to pass to satisfy in order to be sent to the whole community. So the events have to be closer than 200 megaparsecs. They have to be localized better than 1,000 square degrees. So these are more or less, let's say, not totally random numbers, but these are completely conservative filters. So just to be clear, the probability of the GW event should be more than 50%. BNS, the classification should be more than 50% BNS. The terrestrial probability should be less than 10%, so less than 10% to be a noise. and the different probability telling you if a neutron star is involved in the binary system and if some ejected matter has been produced after the mergers should be larger than 50%. So as you can see, we don't take too many risks right now. We just assume that things have to be above 50% here. For neutron star black hole mergers, I didn't put any limitation in terms of distance, as neutron star black hole mergers could be localized much further away than BNS. And so if I put a 200 megaparsec distance threshold, probably you would get almost zero NSBH events. So I didn't want to put any limitation here on the distance threshold. For the localization accuracy, I also put this threshold 1000 square degree, which is still high actually. The probability of the event should be more than 50%, and same thing for the terrestrial probability. So for the probability of the event to be a noise from the detector. So these are the current filters setup, and I will compare these filters to the two significant NSBH alerts we got so far. As I told you, we do not process BBH. And if you look at the NSBH event of May, so of last May, actually it passed all the selection criteria except that, as you can see here, the localization was completely, crazy. So I could not send anything like this to you because, we just don't know where the event is, and it's just a waste of time to search for something in such a huge part of the sky. So for this event, the localization accuracy filter makes the event to be discarded. For the event of the 2 days ago, so 27th of June, so again, all the filters were passed, except we were not very lucky, but except that the event probability was just under the 50% of chance. So the classification from LIGO Virgo, it gave us 49% of chance to be an SPH. And so it didn't pass the criteria. So it's a bit a shame. Maybe I should be more flexible on this. Because for example, this event had a very well localized region in the sky. The distance was okay, so it's a bit a shame that we were not able to process it just because of 1% here. Classification was not on our side, but this is just to explain you why you didn't receive this event, so for example, automatically from ground map.
I've got a question for that. Would it make more sense perhaps to look at the combined probability for NSBH and BNS? Because if the probability is split between those two, it would still look interesting. But if it's split between binary black hole and one of these, it's not so interesting, I guess.
Yeah, you're right. It's an interesting filter, the improvement for such a filter. So for this event, it would not have changed anything because we got 48% of chance of being a BBH and the rest to be terrestrial. So BNS was not favored at all. But for this event, I don't remember the classification. If we got, I had to check, but if BNS classification was also favored on this kind of event. But that is true that if we have some classification that is more or less split between NSBH and BNS, we should favor them. Yes. Yes, that's a good comment. And of course, if it satisfies the other things, the other thresholds. All right. So I will finish on the different ZTF candidates that have been reported on the GCN circulars just following the alert of this NSBH event, so the event of 37C. So our colleagues of ZTF managed to detect 4 potential candidates optical transient candidates for this event. So they generated the GCN at that time. So it was almost 7 hours, I think, almost 7 hours after the trigger time of the GW event. So they proposed those candidates to the scientific community. Then, if you remember well, so I was on duty for Grandma, so I was very busy to monitor the things of what the Grandma telescope were doing, etc. So I got some latency sometimes. I apologize, but I tried to send you a mail 4 hours after the trigger time of the GW event, just to warn you that actually we got an interesting NSBH event that was not actually processed automatically, so you didn't get any alert from your side. But we decided in Grandma that it could be interesting, and so we decided to send a kind of manual warning via mail. So that's why I sent this mail at that time. So after the ZTF candidates were reported on the GCN circular, like few minutes after, you got a mail from Sarah telling you that those candidates were interesting targets to observe. I also put Slack messages because I was not sure that people would be okay with only this mail just 1 hour after the ZTF circular. So you got the Slack message I sent to you just with this list of candidates. And I was able to push the ZTF candidates in the KNC website just almost 7 hours after the first ZTF circular time. So I really apologize for this very late manual ingestion of this ZTF candidates. It was because I was on the rush of the Grandma observations, and so I didn't have time at that time to send the things on the KNC website very, very quickly. So a few hours later, our colleagues from Atlas, so this is the circular from Atlas here, claimed that 2 of the candidates were actually detected in the archive data at a low signal to noise ratio threshold, but still something detected, and prior to the gravitational wave trigger time. So they discarded these 2 first ZTF candidates. And so I tried to send you quick messages on Slack to stop observations related to these 2 events. And then almost a day after the first claiming of these 4 candidates, the ZTF posted a new GCN circular, and so just discarded all the candidates thanks to their revisit observation. They could claim that the evolution of these 4 candidates were not compatible with a fading or rising flux evolution. It was pretty flat, so they just discarded these events. And I'm sorry, I sent a very late information about the fact that those events were no longer credible candidates for this GW event, but at least you got a Slack message telling you that you should not actually stop observation if you plan to observe it. Of course, for those who already observed these candidates, we will analyze the image, and I will just show you this slide now. I received for these 2 candidates, so AAPT-UDB and AAPT-USA, some images from Denis. I think, I don't know if Olivier is connected, but I think Olivier took images also, but I didn't see them on the Kilonova Catcher website. And I got also images from Michael here and from Adam here. I show you here the limiting magnitude I estimated right now because the candidates were not detected in these images. This is a preliminary analysis, quick analysis, but well, at least it's compatible with the non-detection, and based on this magnitude reported by ZTF, we can't say anything about these candidates actually. But it was a good exercise, and from my side, I was really happy to see that you were very responsive and and very happy also to try to take part on this characterization of these candidates. So, which is one of the main important tasks we will have to do for this run. One of our 2 tasks is actually to characterize the different transients that could be detected by others. We will better characterize the limiting magnitude of these images. I think it's also a good exercise for you to know at which depths were your images, and so we'll try to do this and communicate this later. I think this is all for this beginning of the first month of 04. So, and especially for this neutron star binary neutron star black hole merger event. So I don't know if you have questions about this. So far we have closed the follow-up campaign with Grandma, so we won't follow up this gravitational wave event anymore. So we won't provide any candidates for this gravitational wave event, and I think it's the case for other external teams.
Mohammed, I think, has a question.
Yeah, good afternoon, good evening, everybody. Thank you, Damian, for this great presentation. Actually, I have very basic question. I'm not sure if it is the time to ask this question. I have read your presentation, which was sent earlier by email. Actually, I want to ask a question about the time of the events. Talking about Kilonova, the first thing we receive is the GW alert, and
Yes.
after that, we might receive GRB alert. So my first question is, if I understood it correctly, it's not a must for a Kilonova to receive GRB. I'm just confirming this fact. And if we will receive GRB, is it correct that the time between the GW alert and GRB is about 2 seconds, as I understood correctly from the presentation? This is my first question. My second question is regarding the Kilonova itself. I can see that you named one of them as red Kilonova and blue Kilonova. If we are observing by our observatory, when do we expect to start seeing the Kilonova, whether it's red or blue, and how long it lasts? I think it was clearly mentioned in the presentation, from day to 2 for the blue and from 5 to 8 for the red. But when do we start seeing it? This is my 2 questions.
So, Michael, you could complete what I'm going to say. So, for the first question, the delay between the gamma ray burst signal and the GW signal. So, you're right. You are supposed to get a very short delay between the 2 messenger, astrophysical messenger. So 2 seconds, it's a kind of rough estimate for the jet to propagate and to produce the internal shocks that are going to make the gamma ray flash. So this is the correct estimate for the phenomenological point of view. But then the satellite, when the gamma ray satellite is going to detect it, so it has to report then the detection. So it can take some time for all of us to realize that the GRB is related to the gravitational wave event. I think now we have joint analysis between Swift satellite, Fermi, and also the gravitational wave detector. So we would know this information very quickly, but it can take maybe a few minutes to get the information. Concerning the Kilonova, the delay, should we wait or should we go very quickly? I would suggest, well, it's a good question. Actually, the time that the rising phase of the Kilonova is pretty short. Actually, it's supposed to be several hours. It's maybe up to 1 day. So, I mean, it's very short. That's why we suggest to people to start as soon as they can. But it is true that it is possible that, for example, the Kilonova is still faint enough when you are on the target and then it's going to rise, and so you would be targeting at another pointing on the sky, and so you would miss it. I doubt that this would happen, but because the rising phase is pretty fast, so that's why for the GW 170817 it took like 10 hours for people to search into the different galaxies, and they found the counterpart at the maximum brightness. The peak of the brightness was at almost 17th apparent magnitude, 10 hours after the gravitational wave trigger. So this is just to give you a rough order of magnitude of the delay you can expect before being able to see the kilonova appearing in the sky. Of course, this depends on the distance of the event. For GW 170817, the distance was very close, so the event was very bright very early. So, which means that you could detect the kilonova even earlier than the 10 hours if you were on the target few hours after the merger time. For the difference between blue and red, it's really model dependent. So typically the blue ejecta is going to fade very much at a fading rate quicker than the red evolving kilonova. That's why we always say that for the blue, let's say blue kilonova, you can expect to have the signal in your image one day up to 2 days after the merger events, depending on the distance. Again, it's still depending on the distance and the apparent magnitude. While for the red kilonova, you could expect to have it for maybe 5 days, but 5 days you have to go a bit deep. And 5 days, it's more for a kilonova, like closer than 100 megaparsecs, for example. So if you are at 200 megaparsecs, of course, you won't have the chance to observe it for 5 days with our telescope aperture. We would need like large telescope facilities to do this. Does it answer your question, Mohammed?
Yes, my last question was, is it necessarily that we will observe GRB, or we should be in the direction of the jet?
So if you have a gamma ray burst associated with the gravitational wave event, so if the jet is completely towards us, you will see a very, very, very bright event. So here there is no chance to miss it. But I mean, the jet configuration, the geometry of the jet and the geometry of the binary system can be different of being just facing us. And so you have more chance to get the jet off axis, to see it off axis. And here, depending on the angle you have between your line of sight and the jet axis, you would expect a gamma ray burst, or the flash of gamma rays that would be much fainter. This is what we observed for the event of August on the 2017. And also you expect a delay of the afterglow emission. So once the jet is colliding with the interstellar medium, it's going to produce X-ray optical light. And so if the jet is face on directly towards your direction, so you will see this very bright emission directly after the gamma ray burst prompt emission of gamma rays. But if it's slightly off axis, you will have a delay of this afterglow emission. It's the time for the jet to decelerate and to expand sideways and to have the emission coming into your line of sight. That's why you can expect a delay for this kind of emission. The delay just depends on the angle between your line of sight and the jet axis. If the angle is very large, you will have a very large delay between the GW trigger time and the afterglow emission. If the angle is very small between your line of sight and the jet axis, you will get a very short delay between, short delay, few hours maybe, between the afterglow emission and the GW trigger time. But for the kilonova is more isotropic emission, ejecta. So for this, you don't have this kind of question of having a jetted emission and be right on the right geometry of the jet to observe them. observe it. So that's why Kilonova is always, well, in terms of directional, the direction of the photons, it's a better case for us, but it's much fainter than the GRB after gray emission. So we can't have all the advantages actually.
Perfect. Thank you very much.
So if there is no other question related to the first months here, I can go to the feedbacks. I just listed a few of them here, and I have a list of others that you provided in the form that Quentin sent it to you a few days ago. This is just to tell you that we have this in mind. I'm not saying that it's going to be corrected right now, but yes, these are typical issues that you raised, and I would just like to give an answer to everybody so that you are all aware about this. So, at the general meeting, you ask us about adding the time at which it would be the best time to perform the follow-up observation. You know, in this observation plan where you have one line corresponding to one pointing, you ask us to add the time at which the observation should be performed so that it's easier for you to schedule your observation in the night. So this is still not added in right now in the current version of the observation plan, but this is a high priority things to do for the updates of the observation plans in our side. So I didn't forget. I just still have this in mind, but it's not done yet. Related to the 4 ZTF candidates I posted on the Kilonova Catcher website 2 days ago, I got a feedback that it would be great for example, maybe, I mean, there is no clear decision here, and it belongs to you to tell me what you prefer, but possibly to add the ZTF candidates in a single observation plan, so one line for each ZTF candidate in your observation plan. And instead of having 4 alerts in the Kilonova Catcher website, having a single alert called maybe candidates for S230627C. And when you click on your observation plan files, you will find the 4 ZTF candidates, depending if you can observe them or not. You will have 4 or 0, depending on this. So I just wanted to know your opinion about that. If you prefer to have 4 single alerts, and so you have when you click on the observation plan, but well, you have only one line, or if you prefer for a given GW event to have observation plan related to the candidates to characterize, and we could call it this alert GW blah 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 candidates maybe. So you can think about this. You can send me your feedback later, or you can think just a few minutes. I can continue to go on this feedback. So some of you also realized that when they were on the alert page, so when they click on participate to the follow-up campaign, and then they click on the display alert, they realized that there was this message they were telling them that there is no observation plan computed for you. Contact the developer team, etc., etc. So I understand that it is completely confusing. It's just a message that is displayed when the sky map that we produce is not actually generated. This actually doesn't mean that you don't have any observation plan, because if you manage to click on observation plan button and you got actually a CSV file with your observation plan, this means that you had an observation plan. And if you scroll down, even if you have this message telling you that you have no observation plan, if you scroll down and you see your table of observation with the different tile IDs, this means that you have your observation plan. So this message is just to actually a bug when the sky map is not produced. And I know it's confusing, but we have to make a correction on this. I think I answered these questions. So one of you asked me, what does the letter C or the other letters means after the name of the gravitational wave event? So for example, here 27C. This is just a letter to give you the chronological order of this detection. So here C means that this is the third detection of the 27th day of June. And so they go from A to Z, and when they reach Z, they go to AA, AB, AC, up to AZ, and then they go to BA, BC, etc., etc., BB before BC. So this is just to rank the events by chronological order on the day for a given day. I have other feedbacks, but from the files I forgot.
We also have a question from Michael Friedberg.
Yes.
I was wondering, so on the observation plan, if you have, say, 10 different tiles listed, does the first one in that list have the highest probability than the lower one? So you should start with the first one on the list and then go down?
Yes. Yes, you should do this.
Okay.
Well, you should do this. Actually, it depends also on the observability of the target. So if the first target, which is the highest probable target, which is let's say your first priority, but is actually going to be observable after the last one, maybe you should try to go for the last one first because it's better. The conditions of observation are better. Try to also optimize the observability condition for your candidates. So if you have this rank 1 candidate, and if it's like very low on the elevation, maybe wait a bit that this target is going to be at higher elevation, better air mass condition, and try to get to make other candidates if they are not grouped in the same sky region. That's my advice. Of course, if this first candidate ranked number 1 highest probability is also one of the best target to observe when you wanted to observe on the night, go for this one for sure.
Okay, thank you. I just want to clarify that.
Yep. But it depends also, on the observability of the target, which is actually not well. If we add the time for each pointing at which maybe we could add the time at which we advise you to observe, because the observability is optimized for this target. Maybe it will help you also to prioritize your observation based on this probability ranking, but also on the time of observations that you prepare from the flow. Maybe I understand that this is very helpful also for you.
You still have a question, Heinz?
No, thank you. That answered my question.
Okay. Damien, if you want, I can go again through the few feedback that we had.
Oh yeah, go. Yes.
So the first one was that it would be nice if we would periodically have a test alert so we can keep refining our workflow for the real alerts.
Yep. So my question would be, do you really want different test alerts, or if you have already one alert that is always the same that I keep for 1 year, for example, is it enough for you, or you prefer to have each month a new alert? Because I created at the beginning of 4.4 a simulated alert, a fake alert, on which I produce observation plans and things like that, and for which you could post your images, test the system, etc. So my just question is, should we? It's okay for us to produce a test alert, but should we produce one per month, or do you just want to have one that you can keep forever? Well, I don't know if the person who asked this is here, but
I don't think so.
Okay.
Yes, Damien, I think, Damien, you are right. I think it would be nice to have one alert a month to practice and together on the same target.
Yes. Okay.
We have another feedback that in the chats who says also that several different alerts would be nice to cover different observatory sites also.
Okay, so I think it's doable. I have to follow this to see this with the grandma alert system, but I think it's okay. For the test alert, it will be so as you could see in the real alert, it's label S and the date and the letter. For the test alert, it's always labeled as MS. It's for mock event, and so just to remind you the difference between the naming, but it will be labeled simulated events by the way.
Okay, and next feedback was that it would be helpful to have 1 or 3 sample images to see what you want to get from the observers. So the newcomers, I guess, mainly.
Yes. Yes. Actually, yes, I can provide this with no problem. You can also already, I don't know if you see my screen. Oh, I will share again. So I think you see my screen.
Yes.
I will just show you that the problem is that you don't know if the images that have been posted in the Kilonova Catcher are what we expect or not, but this is just to show you how you can find the images that have been sent by other people of the community. So by going into previous events, you can here search for an event. So for example, if you type GRB 221009, because we got a lot of images for this event, you can go to observation list. You can see who posted this, and you can, for example, click on this link. So this button here is just to visualize the image. Maybe it's a bit slow. I hope no, because it has to download the image from the servers, from the image server. So it's loading. Probably it's going to correctly load the image. I am on 4G at home, so my internet connection is not that fast. It's because Michael sent a huge files, maybe. So it's going to load. But I can show you another example. I can show you for the alert of no, I didn't produce the alert, sorry, the TF. The TF, this one. If we go, for example, if we go to Denis images, for example, so you will be hopefully close this. So when I was at the laboratory, it took me a very few seconds to load this, but it's just to tell you that you can have a look to all the images that have been posted for the different follow-up events. You can have a look at these images that are pretty good, and you can also have a look at the feeds header that have been produced by the astronomer here. Of course, it doesn't tell you if we in Grandma validated it, but you can at least ask us the question if this image is the typical quality image that we expect for Grandma. And you can also download this image by save the feeds, and then you got the image locally on your computer so that you can analyze it on your own side and look at how it looks like. It's something like that. So you can do this for all the different images that have been posted on for different from different events. I can also provide you 2 or 3 images that you will be sure that will be the good quality, of course. But don't hesitate to have a look to what others have done and for different kind of follow-up campaigns. It's also very interesting.
Okay, maybe next feedback and last feedback, actually. I don't know who asked that, but I said, I would like to use the Gaia filters because I have calibrated my CCT with catalog Gaia, but it seems not recommended.
Yes, so I don't know if this person is connected today, but so if you only have Gaia filters and you have optimized your setup with Gaia filters, well, we are not going to tell you no, don't use them or throw them away. Use them, but it's true that we favor here in this kind of sense narrowband filters, even if you lose in sensitivity because it's narrowband filters. We prefer to get color information on the source rather than having detection and no information on the color. But of course, if you have Gaia filters and it is optimized for your setup, please use them. It's okay. Don't how to say that, don't let you tell you that you can't observe because okay, it's not the right filter set. Okay, we will deal with that. We just encourage people to use narrowband filters or Johnson-Cousins filters instead of clear or luminance filters or Gaia filters, because it's not optimized for science. But if you have this setup in your hands and you can use it, just use it. It's okay.
Are there other feedback you'd like to share with us? Okay.
So maybe me, I have a question to all of you. So before closing the meeting, do you think it's useful that we do this? Well, I think 1 per month is largely enough, but do you like to have this kind of interaction? Do you think about having another kind of type of meetings or things like that? Don't hesitate also to share your ideas about that. Me, I just try to give you the information, the news about. I think it was good also to make this meeting after the first month of 04, especially because you receive almost nothing. So you might be afraid of, am I doing things wrong? Actually, no. So it's just normal. So, okay, I will try to. Well, the summer is going to come. I will be connected during the summer. I will go on holidays on October, so I will still be able to organize things like this for during the summer. But okay, we can keep this kind of meeting if you think it's a good idea.
Yes.
And hopefully next month we will have the BNS events of the century. We can ask for this.
Fingers crossed.
Yeah. So I think we can close the meeting now.
All right.
Yeah.
I'll have a good night, everybody.
Thank you very much.
Thank you for
Thank
thank you for all.
Thank you.
See you.
Yep,
See you
thanks,
next
guys.
Bye.
Thank you.
Thanks, Damien.
Merci. À bientôt.
À bientôt.
Merci beaucoup.
Du coup, Quentin, si tu as l'enregistrement, tu pourras me l'envoyer et puis
Ouais.
j'essaierai de le diffuser, ou alors tu peux le diffuser toi-même en vrai.
Ouais,
Les planches peut-être aussi.
Ouais.
les planches aussi, ouais. D'accord.
Très bien.
Merci beaucoup.
Ah, Marc,
Andrew,
Marc, j'ai
Oui.
pas oublié ton commentaire sur la troncature là de.
Oui,
Ouais.
bon, c'est un détail.
Faut que je-
On s'en sort quand même.
Ouais, non, mais il faut corriger ça parce que c'est
Oui, oui.